Bismillahirrahmanirrahim. Today we will learn how to protect our company's network from becoming a transit route for different ISPs. If our company's edge router is connected with multiple ISPs, then the routes from one ISP pass through our company's router and forwarded to the other ISP's network. And in the same way, routes from the second ISP pass through our company's router and go to the other ISP. We should protect this to save our company's resources, bandwidth, and hardware resources. First of all, we will see our topology. In our topology, there is one company router. Its name is R1. Our R2 is ISP1's router. R3 is ISP2's router. Our company is connected with these ISPs through BGP. Important commands are provided in the page, which we can see. For R1, R2, R3, the commands will be used as given in our file. We will start our configuration, and in first step we will see the issue, and after that we will resolve this issue of transit routing. First of all, I will configure IP addresses for our company's router R1. All addresses and networks are given in the topology. We will implement them. Configure terminal INTF0/0, no shut, IP address 192.168.12.1, 255.255.255.0. I have provided private IP addresses here for simplicity. In the same way, INT F0/1, no shut, IP address 192.168.13.1, 255.255.255.0, INT loopback 0, IP address 1.1.1.1, 255.255.255.0, INT loopback 1, IP address 1.1.2.1, 255.255.255.0. In the same way, at R2, configure terminal INTF0/0, IP address 192.168.12.2.0, no shut, INT loopback 0, IP address 2.2.1.1 55 0, INT loopback 1, IP address 255 0. In the same way, R3 will be configured. Configure terminal INTF0/1, no shut, IP address 192.168.133.255.55.0, INT loopback 0, IP 192.3.3.1.1 255.0, INT loopback 1, IP all threes /24 0. We will check connectivity from our middle router. Do ping 12.2. In the same way, ping 13.3. Our connectivity established. Now we will configure BGP global configuration mode, router BGP1 for R1 BGP1, neighbor one 192.168.12.2, remote AS2, neighbor 192.168.13.3, remote AS3, and we will advertise our all networks in BGP. Network 192.168.12.0, (255) 0, 192.168.130, mask 255 0, loopback 0, 255 /24, our other loopback 2.0, (0), in the same way, ISP1 exit router BGP2, neighbor 192.168.12.1, remote 1, network mask 0. Our loopback addresses, our neighbor is up 2.2.1.0, mask 255.55.0, network .0, mask 255 and our second ISP will be configured in the same way. Router BGP3, neighbor 192.168.13 or 1, remote AS1, network 13.0, mask /25. Our neighbor is up. Sorry, we have to configure loopback here. 3.3.1.0, mask 255.0, network 3.3.2.0, mask 255.0, network 192.168.130, mask 0. We will go to our middle router and check the BGP routes. Do show IP route BGP. Do show IP route BGP. Network 3.3.3.0, mask .0, we can see that routing is enabled and working. Here we can see the issue. Our requirement is the networks advertised from ISP1 and ISP2 should come to our company's router, but they should not go further to other ISP's network. We can see here that in ISP1's routing table, the routes advertised from ISP2 are available, which are these two routes starting with 3. Our requirement is to block these routes from coming from one ISP to other ISP's network, because they are using our resources. We will check our routing table in ISP2 router. Do show IP route BGP. Here we can see that the routes coming from ISP1 are using the path of our company's router, and our company's router has become a transit, which is not acceptable. For this purpose, we will use AS path access list to stop these routes. In AS path access list, if we use this hat sign, it means that start of string, and if we use this dollar sign, it means end of string, and if we use both of them, it means that the AS path is empty. And AS path for a router which is advertising its routes in BGP is always empty. Therefore, the routes advertised from local router will be visible at both ISPs. The routes coming from one ISP will be filtered to go out to the other ISP. Let us configure it. In first step, we will define our AS path access list. IP AS path access list 1 permit start of string and end of string. It means that empty string value, AS path value is empty. Then we will configure route map. Route map no transit. No transit is the name of the route map given by us. Then permit sequence number, Next, match AS path. AS path number is 1, which we define before, and in next step we will apply this route map. Router BGP 1 neighbor 192.168.12.2, our first ISP. Route map, no transit, direction out. Same way for other ISP, we will configure 13.3 exit. Now we can confirm that these routes are filtered. If not filtered, we will clear our BGP process, do clear IP BGP star. In the same way, other ISP router we will check and clear, do clear IP BGP all. We will check our routing table again. Two routes coming from ISP2 are filtered now. In the same way, we will check routing table of our ISP2. There were 5 routes in this routing table before applying the route map. Now there are only 3. 2 of them are filtered, which were coming from ISP1, and when we check our company's router, we can check its routing table for BGP, do show IP route BGP. Here we can see that all routes are available coming from both ISPs. In this way, we protect our company's router from becoming a transit route for different ISPs. Thank you for watching.